Thanks, Ricky. Everybody hear me okay? So the lab's working great. Well, it's great to be here celebrating ETS and Z-Prime's 10th anniversary for this event. We're thrilled to be a sponsor and helping celebrate this accomplishment. So good job to the Z-Prime team. We want to spend a little time talking about the way Siemens and our customers that we're working with see this emerging and evolving grid in the distribution space specifically. And we've started talking about decoding the future of energy. And when you think about the OT and IT convergence that's happening at the edge of the grid, there's lots of information technology and operating technology deployment and development that has to happen at the grid that's different from anything that we've ever done in the past from a control center standpoint or from a distribution operation standpoint. And so we're going to share a few points today that hopefully bring some of these thoughts home and at least position the next few days to talk about amongst ourselves, to talk about the things that we see that need to be done at the grid edge to basically enable this future energy state that we all desire. I like this picture because the consumers that we all used to serve as electric utility operators were easy to forecast, right? We knew what loads were inside those homes. They're typically water heaters, air conditioners, lights. And we would typically, utilities would organize those customers in classes. We did class cost of service. We said this is a residential group of customers that has no electric heat. This is a group of C&I customers that operate businesses of a certain sort by SIC code, sorted by SIC code. And these were easily forecastable consumer behaviors. The utilities could forecast their distribution investments for many years into the future, do integrated resource plans, and actually present to a regulator a fairly accurate forecast of what's going to happen on their electric systems over the next 1 year, 3 years, 5 years, 10 years, based on the socioeconomic development in their areas and the economic development that's happening overall. Contrast that with today's consumer, and we've coined this term prosumer in the industry, and because sometimes this entity produces electricity. So it's much like a generating unit that we would have formerly sort of managed on a central basis, and the utilities would have discharged it and dispatched it across the entire need of the electric system. Today, we're going to see millions of these endpoints emerge on the distribution system, connected to an electrical system that's really never been designed for this two-way flow of electricity. And compound this complexity with the behavior change that we're seeing at these endpoints. So, you think about the sleepy old customer that was easy to predict. Now these behaviors are difficult to predict. A customer shows up in the middle of the day with their electric vehicle, pulls into the garage and plugs it in. It's a load that's 1/3 or 1/2 the size of the entire home. If it's an F-150 Lightning, it's maybe bigger than the entire home. And so they plug the vehicle in for a few hours, take off and go run some errands, come back home and plug it in. The entire behavior of this endpoint, if we can call it that, these consumers that we serve, has become completely dynamic and has taken all of the forecasting ability and ability to look into the future and required us to introduce a completely new set of concepts to even understand what's happening at the grid edge, let alone forecast its behavior. Just to reinforce some of these points, so we've talked a lot about this prosumer and customers adopting these technologies, and just to remove any doubt from anyone's mind about how fast this is happening. There are 25 million homes today that have smart thermostats. So it presents a huge opportunity for utilities to reach out and touch those devices and create the kinds of flexibility that they need to basically manage this dynamic distribution system that's happening today. There's 6 gigawatts of behind-the-meter solar already deployed, and more of this solar deployment's happening around the country, and we'll talk about that in a minute. We expect to see 30 million EVs by 2030 in the United States, and if Eric's here, we're seeing 6 times the number of energy storage deployments in the U.S. in this 20 to 25 year period, 20 to 25 time period. There's a lot of drivers that are causing this acceleration. So the FERC has implemented some rules that are now going to enable these endpoint generating assets to become part of the organized markets. So in California and in New York, we facilitated a workshop at Distributech back in February where those 2 ISOs and 2 distribution utilities within those ISOs talked about the challenges that are going to involve working with aggregators and actually bidding that aggregated load into an organized supply market that's fundamentally different from being able to interconnect a large single distribution source and dispatching and operating that generating asset in an organized market. and the constraints that we've historically been managing on the transmission system, where we've had long-term plans and utilities have been able to make long-term transmission investments. Now these distribution constraints are going to emerge, and how regulators will allow utilities to make investments in those distribution systems will be significantly different than what we've seen in FERC and FERC's rules on transmission operations. And so the primary challenge for distribution utilities, we think here in the near term, is going to be to focus on non-wires alternatives, figuring out how to adopt more and more of this distributed generation onto their distribution systems without making major capital investments in reconductoring and raising distribution voltages and replacing assets out on the edges of their system. So we think FERC 2022 is a big driver of what's going to happen in the distribution system, at least in organized markets in the US in the near term. The government is actually helping accelerate this deployment, and we did a bit of a research study on DER deployment and DER management requirements by utilities earlier last year, and we thought, well, if we're going to figure out where the biggest deployments of PV are, we should go to the states where the sun shines, right? So we thought the utilities in the Southwest and the Southeast we'd see the biggest adoption, the customer adoption of rooftop solar, and what we found was the states with the greatest rooftop solar adoption by residential customers were places where the financial incentives were the greatest. And I think 6 of the top 10 states were in New England, which you'd think that the sun never shines in New England. And so we recognize that financial incentives, tax abatements, rates, incentives provided by the utilities, and then government low interest loans or interest abatements by governments, either state, local, or federal governments, provide a significant accelerant to deployment of distributed solar, distributed generation. The infrastructure funding bill that just passed with $369 billion of funding available to accelerate these deployments, we're going to start to see this accelerate even more. And then finally, net zero goals are top of mind for everyone, whether it's an industry or a company or a utility or the customer base. Everyone's driving some net zero target, either by 2030 or 2050. All that's going to involve more and more of this behavior change at the distribution endpoint, at the edges that we talked about earlier. And we can't lose sight of the fact that there's the emerging cybersecurity threats from all of this endpoint connectivity. One of our customers said that 80% of the distributed solar that's deployed on their distribution system is managed by a single company's inverters. And that company actually has connectivity to those inverters via internet connections or other kinds of telecom. So imagine the vulnerability that gets created by a single entity being able to be maliciously hacked somehow and then ultimately affect the behavior of 80% of the distributed generation connected to that utility's electric system. It's a significant challenge. We think that we're sitting today within the next 2 years where we'll see 387 gigawatts of flexibility at this distribution endpoint, at these distribution endpoints. So if you think about the total capacity of the United States, we expect to see almost 25% of that, nearly 500 gigawatts by 2050, emerge as loads that distribution operators can actually reach out and touch and manage to effectively manage their electric systems, things like voltage control and protection and control of these distribution feeders that they've heretofore not been able to access. And if you don't believe that number, and we've all been in this when will this really happen mode, all we need to do is look backwards. And we've partnered with a couple of partners we'll talk about in a bit shortly here, but these are slides that our partner Energy Hub provided us. And if you look back to 2016, the amount of flexible capacity that's under their control, that's under their management over this last 6-year period that you're looking at this slide, reaches 1,300 megawatts today. And this is just one supplier in one part of the industry, again, talking about flexible demand response capability. And you can see that it's an exponential growth over the last 6 years. On EV enrollment from, again, another slide from Energy Hub, if you look back only over this last 3 to 4 years, you see this exponential growth in megawatts of connected EV charging, connected to distribution operators that actually have access to these EV chargers and can use them to make corrections and modify the behavior of their electric systems. And so again, looking backwards 3 years, we see an exponential growth. in storage. And so there's no reason to believe that going forward, considering the accelerants that we're seeing, that this exponential growth is going to continue. And the real question is, how do we help distribution operators in the United States actually be ready for this? And the last slide is the battery growth slide. So, this demand response, electric vehicles, storage, this is just a 3-year chart, and you can see the 3-year exponential growth that we've seen in battery growth, again, managed just by Energy Hub. If we were to lay out all the other vendors that are in this space competing for this flexibility market, we'd see that there's plenty of evidence that looking backwards, we've seen an exponential growth, and looking forward, we'll actually see that again. We think the biggest challenge for distribution utility operators is going to be how to actually manage these endpoints. And they've historically grown up in an environment where we buy, they issue an RFP, or vendors all compete for a piece of a customer's business. And we lock these customers into a large monolithic application portfolio that allegedly will meet their requirements for years into the future. So a utility typically hires a consulting firm, they write a big extensive RFP, they go to the market, all of us fight with each other to actually win that deal, and we find ourselves stitching together solutions for the future with tools of the past. And if you think about the way we've historically served this market, we've served it from the inside out, right? It's been a one-way flow of electricity, whether we're talking about energy management systems for transmission operators or ADMS systems for distribution operators. We've always thought about enabling the utility to manage the flow of power from their central generating stations. And in order to enable this two-way flow of electricity, we think an entirely new approach is required. And we think that approach means building a set of modular applications that customers will be able to buy individually and incrementally as their needs evolve. And we've recognized that we're not going to be the only provider in this space, and so our solutions have to be interoperable with the portfolio of investments that distribution operators have already made. And so this concept of interoperability and flexibility is really designed so that we can develop a set of interfaces and integrations that customers can acquire and deploy in a way that makes their ability to meet these requirements going forward much more faster and flexible and open. So this concept of rethinking distribution grid management using this incremental approach is something I think we're going to hear a lot about over the next year or two as all of us begin to talk to the utilities that we serve and think about how we enable them to move in this transition incrementally with incremental investments as their requirements emerge. For us, we think that openness and frankly the industry, the openness and collaboration will help us gain speed. As these utilities are struggling to meet this exponential growth in DER adoption, the rest of us have to figure out a way to catch up to the utilities and actually support them in this transition. And we think openness and collaboration is key to making that happen. First, by starting with a group of customers that are informing us with our requirements. And so we've historically tried to build product roadmaps, using the crystal ball, right? We study what's happening in the market. We give that to our R&D folks. They build software. We introduce the products, and they're either too early or they're too late, and we struggle again to meet the requirements of the market that's changing this rapidly. That might have worked fine in the past, where things were easy to forecast. The markets were more predictable. But today, with this dynamic behavior of the endpoints that we talked about earlier, we think there's an entirely new approach to software development that has to take place. And so this ecosystem of partners that we've selected, these are leading utilities globally that have basically exposed us to their use cases and said, look, can you help us develop the next incremental piece of software that we need? And in many cases, these are products that aren't on the market yet, things that enable behind-the-meter DER behavior, for instance. And on the right side, we've recognized that, so the headline on this slide is from ecosystem to ecosystem. While we'd love it for our customers to use our products from end to end, I think we recognize today that there's leading vendors in this space that we need to pre-configure our solutions with, right? So Energy Hub's a leading vendor, and we'll talk a little bit more this week about the announcement we made at Distributech that Siemens and Energy have become strategic partners in this DER management space. Esri from a GIS or geospatial data management space, and coupled with our network modeling capabilities, we think we're not going to build another GIS product. They're not going to build another network modeling product. So we're looking for ways for us to collaborate and integrate our products with SEW in the customer engagement space, over IT in the mobile workforce management space. So we're beginning to build this ecosystem of partners where we've selected leading vendors in this space that would work with our products and ultimately be able to provide an ecosystem solution pre-integrated with API first thinking to address some of these emerging challenges at the end at the grid. So the Siemens Energy announcement that we made at DistribuTech, we'll talk a little bit more about that week. Seth Frater-Thompson's here, as are a couple of other folks from Energy Hub, so I'd encourage you to reach out to him or us to talk a little bit about what this means. Again, we think we're going to take the things that Siemens does best, right? Grid control, grid simulation, grid modeling, and couple that with what Energy Hub does best, which is customer engagement, working with vendors and provide to utilities an aggregated vendor outreach solution. And so this is an example of the way we think vendors are going to need to move forward to actually meet these future challenges. So I'll stop right here and say we're about to enter a new era in this DER management space. And so, you know, you've heard a lot about DERMS and what DERMS means. And I think if we decouple that term into the individual component parts, you'll find that many of them are already met by the deployments that utilities have made in their ADMS investments. Some of the capabilities are already met by the utility investments in DR or demand response management systems. And what needs to happen is some way to fill the gaps that both of those application portfolios haven't yet addressed in this DER management space. And we think you're going to see some partnerships emerge over the next 12 to 18 months that will work together to address those challenges. So I'll stop right here and let the keynotes continue. I guess we have a series of keynotes today, so thank you very much for having us today.